A while back, a viewer wanted to know how we write programs to cut a tapered threaded connection. That's a 2 7/8 regular pin. Here's a quick, simple program to write it or to cut it. It's a 3-step roughing cycle, and it's a 3-step finishing cycle, and then 1 threading cycle. If the ID is big enough, I have a tool to put a 10-degree run out in the ID. This ID, we're not going to be able to do that. You'll see why here in a little while. Let's get back to this. The easiest way for a beginner to write a program, especially here on the machine, is to do it in a 3-step process, so you don't have to do a lot of math. This is an API print for 2 7/8 regular pin. Here it tells you that the nose, the major diameter at the small end, is 2.156. Over that length, 3 3/8. At that point, it's going to be 3 inches in diameter. So now we know a starting diameter, a finishing diameter, and how long. So that's what this program is doing. It's going to alter mode. There's my starting diameter. My starting diameter is 2.156, like the book says. The next step, I'm going to 3.0154, negative 3.4355. This is different than what the book is showing you. I did the math. For the extra distance I'm going, that's how much it's going to change in diameter. I can show you a quick, easy way. The book, I have a cheat sheet in my book. Anyway, once it gets to that length, you're going to go up to whatever the OD size is. In this case, it's 4.220. And then your next step, you got to go back to your starting point. So this would be to 0.030 and then back to 0. To write this, it's super simple. We'll do an alter just so you get an idea. Say I'm starting fresh. That's where you put in your first dimensions. At 0, at 2.156 diameter, that's where I want to start my cut. From that point, I would hit line. In this case, I'm going to hit alter because I already have the line in there. I would hit line, and then all these right here options would show up. In my case, I want to go left down that way. So you hit left down, and then to that diameter that I was talking about, and that length. This is going to be a part, so you have to put part. I'll show you the difference. This is the face, so that's going to be a part as well. This section here, it's blank. There's nothing there. That's part of what we're cutting away, so you have to put blank. That option is when you get to that line, it's going to want to know, is it a part? Is it part of what you're cutting, or is it blank? That's blank. As well as these last 2 points. You're not leaving anything. All that's getting wiped out. All this is getting wiped out. Recalculate, create. Okay, the same process you would do for the cylinder diameter now. The cylinder diameter and the bevel. Again, it gives you a diameter for what the cylinder diameter is supposed to be, plus or minus 1/16. And then your bevel diameter. The bevel diameter, we're not going by what the book says, we're going by what the customer's asking for. This length, you can do the math. Since we know that this is 3 inches right here, you can do the math backwards and figure out how long this flat's gonna be. It's real easy. If you just want to guess, just say like a 1/2 inch. And then you can figure it out from there. In my case, at 2.890, at 2.800 inches in, is about where that diameter is going to hit that taper. So that's my starting point. And again, it's the same thing. From that starting point, I would hit line. In my case, I already have it. I'm going to hit alter. Line, and then I would hit left. We're going to go left at that diameter right there. Or no, at that same diameter from the other point, the starting point. We're going to this length. And that's where our face is going to be. Again, that's going to be part. Recalculate. There's the face. And right here is where I need to put the bevel. The OD is 4.220. They want a bevel of 60 thousandths per side. So that would mean that I need to start the bevel at 4.1. From there, from that point, I would hit line. In this case, I already have it, so I'm going to hit line. There's your options that are going to show up. I'm going to hit left down to cut the bevel. And there's my diameter that I'm stopping at, 4.22. Actually, you know what? Let's change that. So I don't want to cut it short. 4.24. I'll show you why I'm doing that here in a second as well. Anyway, it's a simple process. And the last part is, oh, I should have done that on the finish. The last sub-program is right here. It's hidden inside this other one. All this is that bevel here in the front. You always have a break edge. They give you a minor diameter, what the bevel is going to be at the bottom. So that, again, that would be your starting point. Then you hit line, go down to the left. On this, you could just cheat if you don't want to do the math. This is why I say this is the one that's down and dirty for somebody that just learning how to do it. The length of that bevel is going to be the length of basically the width of the thread. So if you're using, say, let's say 4 threads per inch, then you know a thread is going to be 1/4 of an inch wide. So just run this 45-degree angle right here longer than what your thread is going to be. So if it's 1/4 of an inch, make this 5/16 of an inch in length. The machine will tell you the diameter it's going to be. And this one here, I'll show you how. Let's see. In this program, I gave it a length, and at a 45, that's longer than what the thread's going to be. And that's the angle I want. So it's going to tell me what that diameter is already. All by itself, because it's a computer. It does the math. At that point, that's what the diameter is going to be. That's what I'm saying. This is an easy way for a beginner to write programs. My other programs do it all in one shot. Did the math. It just saves you a little time. This is just a beginner's program. When you run that program, this is what you end up with. It's dirty.